We will start Schrodinger's wave equation. A scientist named Schrödinger has given this equation to find out the position of an electron around the atomic nucleus, or which rotates or which moves around the atomic nucleus, and because of it is known as Schrödinger's wave equation. Let's begin with the theory here. Now, the calculation of the probability of finding the electron at various points in an atom was the main problem before Schrödinger. He has one problem, that how can we find the exact position of an electron which moves around the atomic nucleus, or which moves in a particular orbital. So to find out that, he has given one equation, and his equation is the keynote of wave mechanics. How it can be written? So it can be written as psi is equal to a sine 2 pi into x by lambda. This is known as equation number A. Now, where psi is the mathematical function representing the amplitude of the wave called wave function. X is the displacement in a given direction, and lambda is the wavelength, while A is the constant. So here, as you can see, X is the position and psi is basically wave function. So we have included both the kind of thing, that if to find out the probability, to have the probability of finding an electron at a particular position, we have to use such kind of an equation, right? Now, let's understand that how it can be further taken. By differentiating our equation number A twice with respect to x, we get d psi by dx is equal to a into 2 pi by lambda into cos 2 pi into x by lambda. This is known as our equation number 1. Okay. Now, this is first time that we have differentiated it with respect to x. Second time we have to differentiate it with respect to x. So what we will get? We get the equation which is d square psi by dx square is equal to minus a into 4 pi square divided by lambda square into sine 2 pi into x by lambda. This is known as equation number 2. Here we know that our equation number A comes into picture. But a sine 2 pi into x by lambda is equal to psi. So we have here the value of psi, and we will put this value of psi into our equation number 2. Let's put this value into our equation number 2. What we will get? Let's see. So d square psi by dx square is equal to minus 4 pi square by lambda square into psi. This is known as equation number 3. Understood it properly? What we have done, what we did is we have differentiated our equation number A first time. After that, we have again differentiated second time with respect to x. As we get the data, we get the equation number 2. After that, we put the value of psi into it, and we obtain our equation number 3. This is the sequence that how it can be possible for us, right? Now, the kinetic energy of the particle, because the particle is in the movement, so it has a kinetic energy. So, the kinetic energy of the particle, which has mass m and velocity v, can be given by the relation, that is, kinetic energy Ke is equal to 1/2 mv square. Let's again multiply it with m on the upper part and on the downer part. We will obtain 1/2 into m square v square by m. This is our equation number 4. Now, as you can see it here, according to Broglie's equation, lambda is equal to h by mv. So let's take, as we have lambda square, so let's take the square of it. So lambda square is equal to h square by m square into v square. Here we obtain the value of lambda square. We can get the value of ke using equation number 4, right? So we are obtaining the values here, as you can see. Now we can write the last equation like this: m square v square is equal to h square by lambda square, right? Now, substituting the value of m square v square, which we have obtained through the kinetic energy equation, that is our equation number 4. So let's put it here: Ke is equal to 1 by or 1/2 into h square divided by m into lambda square. This is equation number 5. From equation number 3, what we obtain is lambda square is equal to minus 4 pi square into psi divided by d square psi by dx square. This is our equation number 6. Go through it properly, as it gives us the idea that how it can be written. Okay? Now, let's move on to the further. Now let's substitute the value of lambda square in equation number 5. So kinetic energy is equal to minus 1 by 2m into h square by 4 pi square into psi into d square psi by dx square. Let's rearrange this. Is equal to minus h square by 8 pi square m into psi into d square psi by dx square. This is a rearranged equation. So here the total energy E of any kind of particle is the sum of its kinetic energy and its potential energy. Okay, so we can write the equation as capital E, which is the total energy of the particle, is equal to Ke, which is kinetic energy, plus Pe, which is potential energy. Now, here if you want to take the value of Ke, so kinetic energy is equal to E minus Pe. So when we substitute the value of potential energy from the total energy, we can obtain the data of kinetic energy. This is as simple as that. Okay, so we can put the value of Ke here, or we can have an equation like this. So here is equal to minus h square by 8 pi square m into psi into d square psi by dx square. Okay, or another way I can write it as d square psi by dx square is equal to minus 8 pi square m divided by h square into E minus P into psi. We have just put the value of Ke here, which is E minus P. Okay, now we can write it like this: d square psi by dx square plus 8 pi square m divided by h square into E minus Pe into psi is equal to 0. This is Schrodinger's equation in one dimension. Which dimension is it? It is in x direction. Whatever the direction it can be, we can find it out using this. Like if you want it in y direction, then d square psi by dy square plus 8 pi square m by h square into E minus P into psi is equal to 0. Now another one can be, we can have d square psi by dz square plus 8 pi square m by h square into E minus P into psi is equal to 0. So in any direction, whichever direction our particle moves, we can find out the value of, or we can find the position of it using this kind of equation, right? Now, this is known as Schrodinger's wave equation for one dimension, any kind of one dimension, okay? Now let's see that how it can be represented in x, y and z. So d square psi by dx square, d square psi by dy square plus d square psi by dz square plus 8 pi square m by h square into e minus p into psi is equal to 0. This equation is called the Schrodinger's wave equation for 3 dimensions. Be specific here. All the 3 dimensions we can find out in the 3 dimensions also. Okay. Next we will see in our next session. Thank you so much everyone.